In this example, we're asked to use a change of variables to evaluate the following definite integral. And our definite integral is x squared e raised to the x cubed minus 8 from x equals 2 to x equals 3. Now, because this expression x squared times e to the x cubed minus 8 doesn't fit any of our integration formulas, maybe we can try u substitution. And when we have a factor containing e in our expression, a good bet is to always let u equal the exponent of e. So in this case, we'll try letting u equal x cubed minus 8. And if u equals x cubed minus 8, that means du equals 3x squared dx. Now we almost see our entire du represented in our definite integral. We have an x squared and a dx. The only thing that we need to do is to manipulate this definite integral by putting a 3 in front of the x squared so that we have our entire du. But to offset that, we're going to add a 1/3 out front. So now we have 1/3 times the definite integral of e to the u du from x equals 2 to x equals 3. Now, since we've changed our expression from x's to u's, we also need to change our limits of integration. The lower limit of 2 and the upper limit of 3 are x limits of integration. We need to change those to u limits. Since we defined u to be x cubed minus 8, let's evaluate u at the upper limit of 3. U of 3 will be 3 cubed minus 8, which equals 19. Now let's evaluate u at the lower limit of 2. That gives us 2 cubed minus 8. Well, 2 cubed is 8, and 8 minus 8 is 0. So our function u, evaluated at the lower limit of 2, gives us 0. So these are our new limits of integration in terms of u. So our new integral is 1/3 the integral from 0 to 19 of e to the u du. Now let's integrate e to the u. The antiderivative of the e to the u is just e to the u. So now we have 1/3 times e to the u, and we need to evaluate that from an upper limit of 19 to a lower limit of 0. Let's evaluate this area function at 19 first. That gives us 1/3 times e to the 19th. Now let's evaluate it at the lower limit of 0. That would give us 1/3 times e to the 0. But e to the 0 is 1, and 1/3 times 1 is 1/3. So a to the 0 is, or a evaluated at 0 rather, is 1/3. And now, using the fundamental theorem of calculus, f of b minus f of a gives us a evaluated at 19 minus a evaluated at 0, which is 1/3 e to the 19th minus 1/3. And this will be the final answer. Or if you choose, you can factor a 1/3 from each of those terms, and the final result could be entered as 1/3 times the difference, e to the 19th minus 1. Either way is correct.